Today we are joined by Charlie Marsh, the founder of Astral, a company that makes next-gen Python tooling. Maybe you've heard of UV. Charlie, welcome to the show.
Yeah, thanks so much for having me on. I'm really excited to be here.
Excited to have you here. Topping the Stack Overflow survey. Most admired or desired. I'm not sure how they broke that out. I've forgotten already, but you're at the top. We talked about you on news a month or two back. But man, everyone is either loving or wanting to love this tool you've come up with, UV. Can you tell us about that?
Yeah, no, thanks. It's honestly, I feel pretty lucky because I don't really spend a lot of my time thinking about how to get, on top of the Stack Overflow developer survey. I get to just spend my time like building the thing and talking to users in the issue tracker and like trying to make it better. And then it just keeps growing. So it's kind of like a dream job in a lot of ways for me. So UV is our Python package manager, Python toolchain manager. We kind of view it as like the one thing you install that then gives you everything you need to be productive with Python. There's a couple aspects that I think make it unique. One is, as with a lot of the things we build, it's really focused on performance. So we think a lot about how do we make things very, very fast. Things like way faster than you thought they could be is sort of the way that we try to view it ourselves. But we're also trying to just take a lot of the complexity out of building with Python. I think like Python packaging has for a very long time been a thing that people have complained a lot about, and often for good reasons. Like users running into problems, people having trouble trying to understand why things are so complicated or things aren't working the way they want. And so a lot of what we've tried to do with UV is cut through a lot of that complexity. In some cases by like bringing more functionality together. So like you can just install UV and then it can manage things that previously you might have needed to distribute across a bunch of different tools. So maybe before you had to learn like 4 or 5 tools, and now we say, hey, here's UV. It can do all of that stuff for you. And then partly also by coming up with some of our own kind of like workflows and APIs that we've put into UV that we think make things basically make it easier to get things right for users. Yeah, we model UV a lot off after, we're very inspired by like how Rust does tooling. So UV is in a lot of ways modeled after Cargo, which is like Rust's package manager. And with Rust, it kind of feels like you install this thing and then everything you do is like very high confidence. Like you kind of like know how to like install dependencies and run code and test code. And like, that's what we want to get to with UV is we want to give people kind of this very high confidence experience of working with Python.
Everything for Rust really revolves around Cargo, right? Like Cargo does pretty much all the heavy lifting. So it's linting, it's doing builds, it's doing all the things.
Yeah. And Rust and like other new programming languages, it has this like kind of second mover, or I don't know about second mover, but it has this late mover effect where they get to learn a lot about like what makes a programming ecosystem nice to work in. And so they got to do like, it's a very different position from when Python was being created, and it was like decades ago, and everything kind of evolved very organically, and it wasn't really clear like how serious things would be or like what was going to change. Like packaging kind of just like emerged as this like organic property of like people needing to share code and like distribute code. And for Rust, it's really different. It's like, okay, we're building a new programming language. Let's learn from all these things that people have built. And so in Rust, like Cargo is very much like a blessed tool. It's like you install Rust with Rust up, and then you use Cargo for everything. And in a lot of places, Cargo is actually kind of like a front end to other tools. Like Rust actually has a formatter called Rust format, but you never really think about that as a user. Like as a user, you just run Cargo format, and that actually runs Rust format. So Rust becomes kind of this like focal point Cargo becomes this focal point for how you work with Rust, and all of that design was very intentional. So for us, it's a little different because we're like coming into this ecosystem that's decades old and like absolutely enormous, which is like the Python ecosystem. And we're trying to both like meet people where they are in a lot of ways and be like, hey, we want to give you better tools that like don't require you to completely rethink like how you work. But also we sort of think about how do we build towards a very different experience and give people something that is very different for people who want to embrace kind of a different way of working. So we try and do actually both those things. Like we try to build tools that are what we would say are like drop-in replacements or like very compatible with how people do things today. But then we also build tools at the same time that are kind of like, hey, if you want to work the way that we think you should be working. Like here's like a very different way to work with Python. And you get kind of different benefits depending on which you opt into. But it's very different from building for Rust, building tooling in Rust, for example, or for Rust.
One thing that, just back on Rust for a second, one thing I read actually on Wikipedia from Graydon, the fellow that created Rust, was just this notion I think is important to mention. He said, let me see if I can get my words right. In Wikipedia, it says this. I'm not sure how you pronounce his last name. Is it Hoare? Hoare? I'm not sure.
Yeah,
Emphasize prioritizing good ideas from old languages over new development. So as he was thinking about Rust, let me prioritize these good ideas from older languages, even some obscure languages, over new development. And I'm going back to the quote, citing languages including, and I left that out because I was trying to paraphrase to a friend. And then it was like, many older languages are better than new ones, and describing the language as technology. This is cool. Technology from the past come to see the future from itself. I just thought that was really, really cool. Like this show, like as we pull back the layers of software, as we pull back the layers of, hey, this is how Rust does it. And so this is how other folks are doing it or whatever. It's this learning from the community at large of software, not so much the Python world or the Ruby world or the Rust world or the Go world. It's like these ideas that are spread across even other languages that I'm way less familiar with, if at all. They impact how you build the tooling you build. And I think that's kind of cool. It's just like this technology from the past come to see the future from itself. That's just poetic and beautiful.
I'm a huge fan of that, like general idea of like cross-pollinating ideas. And yeah, I think about this a lot when we're building tooling. It's like, I mean, it's not totally unprecedented that we encounter some problem that no one has worked on before, but it's pretty rare. Like most of the times when we go in to solve a problem, it's worth looking at, okay, well, like how do other ecosystems or how do other tools like approach this problem? And like before I worked on UV, we built a tool called Ruff, which is a linter formatter. It's sort of like in Cargo, in Rust, it would be like our Rust format, our Clippy. In JavaScript, it would be like some combination of like prettier and ESLint and all that stuff. Mm-hmm. So it's like a static analysis tool, formats your code, it like fixes issues. And when we worked on that, like so many of the design decisions and design questions just came down to like, okay, well, like let's go look at a bunch of other ecosystems and how they do this. So we looked at like Ruby, like obviously we looked at like Prettier a lot and ESLint and like decisions that they had made. We looked at like Rubocop and Ruby. We looked at Clippy, and we still do that today. And so like, I don't know, I think, and even with now, like we're as a team at Astral, we're like about 20 people. And as we've like put together that team, it's also been very intentional that like I've tried to suck people in to Python. Like it's not like we only hired people who have worked in Python their whole career. Like it was very intentional that we actually brought in people who in some cases like had done almost no Python and brought in very different ideas, like people who had written tons of Rust or a lot of Go, even people who like spent most of their career in the web ecosystem. Because I like bringing in those different ideas and having those different perspectives and like bringing different energy into like a programming ecosystem. So I'm a really big fan of stealing basically good ideas from other ecosystems and like looking at prior art. I think that's like kind of always the first thing that you should do.
Yeah. Anybody who's against that, just, I don't understand that logic. Like, why would you not look at...
if it's my art, that's the only time I'm against it, is if it's my art.
Well, I think in programming in particular, like, when you look at a package manager or a registry, why would you start from zero? Why would you... I mean, first principles for sure, but based on the past, based on other implementations, not based on, I'm not looking at you because that's your thing. It's, no, let me become wise because of what you've done or the road you've gone down,
right,
and then begin from first principles based on this just new vantage point that you would otherwise not have if you didn't look. It just doesn't make any sense to me.
Yeah. Let me share a little history, which illustrates exactly what you're saying. So I was in the Ruby community, Charlie, Adam and I both were, and Ruby had, average package managing in the pre-Rails day. And then Rails got so big and had so many people using it that it was like, it just wasn't enough. In fact, we had this whole vendoring thing, and eventually, there's a couple fellas, Yehuda Katz being one of them, who was like, we're going to fix packaging for Ruby. And Carl Lersch, I'm not sure if that's how you say his name, but he was the other one who I remember. And they built Ruby Bundler, which eventually was like first partied into the whole thing and became the package manager for Ruby, and it was much better. They learned a lot, they made a lot of mistakes, and they made a lot of people happier than they were. And then, as you may know, Charlie, Yehuda and Carl went over and built Cargo for Rust. And so they took their learnings from building Bundler and the stuff that was good, and then they dropped the stuff that was bad over to that, built Cargo. Cargo became awesome. Everybody inspired by Cargo, yourself. Now UV, based on Cargo inspiration. And a cool full circle moment is what I read. I'm sure you know about this. Maybe you don't. RV, which is a new effort by Andre Arco and a few other people to basically build a new Ruby thing, which is based on principles and things they like about UV. So like it's a full circle inspiration there that is just really cool and just shows how stealing good ideas from other places is like, it makes us all better.
Yeah. I do love that story. I thought that's where you were going to go. Which is, it's very cool. And I don't know. I mean, I think it's actually hard. Like if you're going into a process, like a language design process or something, this idea that you have to go do a bunch of homework, I think is actually like, it's work to like go out and like see what decisions people made and why, and like why they, whether they've worked out or not. And there's always a temptation to think that your problems are like different and new, that like no one has really like solved these before. And it is often the case that like you're working on a problem that's not totally new, but is new in some different way. Like I'm sure most problems that you work on have some context that makes them new or different, right? And so there's a lot of like taking in information, looking at what people have done, trying to understand like why they made the decision, like what the impact has been, like has it worked out or not?
Right.
But then also understanding like why your context is different and like why, how you need to adapt it. So it's a big, I'm always kind of like harping on that, especially now as I've gotten a little bit, not that I'm like hugely involved, but as I've gotten more involved in Python standards, and I get pulled into different discussions or different ideas, I'm kind of always trying to push on, well, how do other ecosystems like solve this? Or have we looked at, there was one proposal recently around sort of like having like default optional features in packages. And we keep trying to bring up, well, let's look at how Rust has done it. And like, there are actually some problems with it. And so let's make sure that we think about like what those problems are and like how they will affect like this design or like ways we could do it better. So yeah, it's not only taking the good ideas, it's also kind of looking at like what could be done differently.
Learning from the failures. Yeah. Or the trade-offs, sometimes it looks like a failure, but actually it was a perfectly reasonable trade-off given their context. But the good news is we don't have that context anymore. And so we can avoid that particular problem. Adam and I, even though we're not daily Pythonistas, we felt the pain of Python package management because there's so much tooling that's useful in Python. It's just massive, as you said. And so we had conversations and shows all about like help us to get rid of our what is it? Not FOMO, the opposite. Like our fear of using Python.
It's more like fear. When I have to install anything in Python, it's like, ooh, I don't know what to do. Is it the right way? What's going to happen?
That's what we're trying to overcome. Yeah.
Right. So my question is like, how did you pick this problem? Because it seems like it's rife for disruption, but it's existed for so long. Like, how did you come to this idea of like, well, we're going to do a new package manager for Python?
Yeah, totally. So like I said, we started with Ruff. So we started building this like static analysis tooling, and I started as an open source project, and eventually I turned it into this company. And when I was looking at what we want to be as a company, it's like, okay, we want to be like the Python tooling company, let's say. Well, if we want to be the Python tooling company, I think we have to like take on the hard problems in Python. And for me, it was like, okay, we have to do something in packaging, because every time you talk to people about using Python, they have this groan, which comes from installing Python or installing packages or setting up the environment. And for me, it was like a lot of people, something that's intimidating is like a lot of people have actually tried this. Like there are lots of tools, and that's because like a lot of people have tried to do different takes on it. And so for me, it was a little bit of like, we have to do this, both to prove that we can, and because it seems like the most important tooling problem in the ecosystem. So if we're going to try and like really like lift up the ecosystem in some way, like this is the thing that we have to go after. And it was, we thought a lot about, we think about this with everything we build, but it's like, why what is like the insight, or like why can we build something? Why would we succeed here? Whereas other people,
that was my next question. Yeah.
Yeah, I mean, I don't think it's that other people have failed, but it's like, why would we, if the space is really fragmented and some users are still having problems, like what are we going to do differently that's going to it's going to overcome that fragmentation or like overcome those problems? And I think part of it is just that we had the resources and like the ambition to try and like do the whole stack. Because if you look at a lot of these other tools, they kind of build on other pieces and they have to like cut the cord somewhere. And so for us, it was, okay, we're going to do packaging and we're actually going to do like the whole stack, like everything from like parsing dependency specifiers, like version specifiers, through to resolution, through to installation, through to managing Python itself, like the Pythons you install and all the versions, through to actually building those Pythons for you. Like we're going to do the entire stack. And so that I think is where a lot of the effectiveness of the reason that we're able to do things differently, like a good amount comes from that, which is we were like, we're going to do the whole stack and like everything's going to be aware of everything else. And that lets us build experiences that kind of work better together and are like more automatic. Like when you go into a project, you install UV and you run UV sync, like we can do everything from we figure out what version of Python you need. We go install the pre-built version of Python that we built. We put it in the right place. We resolve all your dependencies. We put them in a log file. We create the virtual environment. We install everything into the environment, and then we run the command that you gave us in that environment. So like all of that complexity goes away. And that comes from being willing to say, okay, we're actually going to try to do like the whole stack. And I think that's where a lot of it came from. I think the other piece is just making good decisions about like where to be pragmatic and where to be like sort of dogmatic, like where to say, this is something we really believe that we're going to like do differently, and other areas being willing to say, okay, we need to do this for compatibility, or like just it'll break too many users, and just like on the margin, trying to make good decisions around behaviors is very hard. I think we've gotten a lot of them right, but some we've gotten wrong, and some we've like changed over time. But like a lot of ultimately that too, a decent amount of this comes from having the resources to like work on this stuff full time, like being able to kind of rally people, including investors, and like bring in investors and say like, this is an ecosystem that's like really worth working on. And like, we can do something like we think really special and different here. And so being able to bring people in full time and really pay, put in all the engineering investment to build this thing, the community investment to like spend all this time in the issue tracker and understand like what's going well and what's not, and fix things for people and be really close with the community and like try to iterate really quickly. So I think ultimately it comes from being able to have that level of ambition of like, we're going to do something really different. And then executing that in a way that I think has been really effective.
So did you have that goal in mind when you started talking to investors? Because like you said, you needed N years to do this, or however many years you think it is, or months or years, probably years, right?
How long it took to build UV? Is that the question?
Well, even like to be able to bite off the entire thing, like that's what your goal is, right? It's like everything. And so if I'm a full-time developer, Python developer at, someplace, and I have this like, I'm going to solve packaging for Python. I got to do that nights and weekends. Maybe I cut back my hours and work on it maybe I convince my boss I can work at it in my 20% time. But like you said, no, we're going to do it all. We're going to do it right. Ground up to a certain extent. We're going to even installing Python through our tools. And so to do that, you raised money, right? Like that was because you need multiple people for multiple years to actually get that done. And so was that your first step, was like, I want to do this and I'm going to go raise money to do this, or I'm going to convince people? Well, how did that whole play out?
Yeah. So the first step was, I started working on the tools before I raised any money or started a company. So like I'd left my last job. I was at a computational biology company. I was in charge of all the sort of like software infrastructure, data infrastructure, machine learning infrastructure. We wrote a lot of Python, and I was kind of like figuring out what I wanted to do next. And I was like looking to start a company, but I didn't really think it would be this. This was kind of like my side project where I kind of like wanted to learn Rust. And so I started building this because I was like, I think this could be cool, et cetera, et cetera. And
And that was Ruff that you were building, right?
That was Ruff at the time.
Okay.
Yeah. And that project then really started to take off. And I kind of realized there was an opportunity to take these similar ideas and extend them to other parts of the tool chain. Like we could build a package manager. At the time, it was just a linter. And it was like we could build a formatter, we could build a package manager. Now we're also building like a type checker and a language server. Like we're trying to build all this stuff. And I saw there was this opportunity. And, I think a couple of things that come to mind. One is like, very, very important everywhere, but especially in this context, to find ways to demonstrate like incremental value and being able to get things out to users incrementally. Like Ruff was a really good project for that because it was a linter. So it's like a set of rules, right? And a set of functionality. And like the core of it doesn't have to be that big, but like over time you can do like more, you can add like more rules, more functionality. So we were able to ship, like the first version I shipped was like not very feature complete, but people could actually use it. And over time we could like extend and grow it. So it was usable very quickly and it grew quickly. And then we kind of expanded the scope of what it could do. It was something we could ship very incrementally. The formatter was maybe a good example of something that's not like this at all. Like a formatter is not useful until it's done. Like it has to be finished. Like it's not useful if a formatter can format like function definitions, but nothing else.
A third of your code.
Yeah. So that was like a bigger challenge where it's like we actually had to iterate, not in private, but like we didn't have like a useful release for like a long time. Like we were like, it was all in public, but it was like no one was really using it until it was done. And then when we got to the package manager, we took, we thought about that a lot. And the thing that we did, we actually built the first, like I started working on it in like October, let's say, of I think 2023. And then we did the first release in February. So it was only a couple months and it was like 3 of us working on it. And the first release, we said, we actually found really good ways to kind of cut like what went into that first release. Like the first release was just a pip compatible CLI. So all it did was like UV pip install instead of pip install and UV VM to create virtual environment. Like it was the CLI now does a bunch of other stuff, like supports like installing Python. We have like lock files, like installing global tools, like all this stuff. None of that stuff was in the initial release. And so for us, it was like the first release, how do we prove that we can do this? Let's ship this very well scoped. It just does pip install and like pip uninstall, right? And like creates virtual environments. And that's actually useful for a lot of people. Like that actually solves a lot. It's not like some people looked at that and were like, oh, it's just faster pip. That's not interesting. And like what we're trying to do is much bigger than that now, but that's what we started with. And so for me, it's like a lot of the focus is on how can let's think like super critically about like use cases and how can we get something out there as quickly as possible. It's like useful to people that we can actually start iterating on in public and with users. And that's kind of been like, that drives, I think, a lot of how we build things. It's like the type checker is similar. It's like the type checker kind of has to be done to be useful. And so it's actually harder to build and you have to be willing to put in a lot more investment over a longer period of time. But when you can find a tool that you can get out a small version of that's actually useful, like just ruthlessly asking yourself, what would it take for someone to actually be able to use this? And then like getting to that and getting into an iteration loop, I think was really helpful because we kind of proved like we could build this packaging stuff. And then from February to, I don't know, August or whatever, we built this whole other part of the CLI and released it. And then we had a huge new launch around that. But, a lot of it is being able to prove that you can do these things and prove that users want them. And so getting something out quickly and iterating from there, I think is like the thing that I always try to find a path to that with the things we build. And proving that you can do it with a small team is also very helpful to yourself and to investors. Yeah.
So did you go the traditional pitch deck route? Like you got a pitch deck that you went around and how did you raise the money?
No, I don't know. I got pretty lucky. Yeah. There was a lot of,
you had friends in the industry or like how'd you get the
It's
money?
more just that the open source was really taking off. And so our fundraisers were pretty easy I don't want to say easy. They were relatively frictionless because we were seeing so much growth in the open source that it was just clear that we were doing something right, basically. And so for investors who are open to investing in open source, because you will find very different investor philosophies around this stuff. But if you find investors who kind of have done open source before or really believe in, the ideas around open source and also how they can segue into like commercial growth, It wasn't, thankfully we didn't have like super challenging, fundraises. So yeah, like it's kind of funny because at the time, like I said, I was thinking about starting a company when I was working on this stuff. And so I'd actually started talking to a few investors, but really just as a way to kind of like build relationships and be like, hey, I'm like not starting a company yet. I don't know exactly what I want to do. Here's like 4 things I'm kind of like playing around with, like building prototypes, like talking to users. And the thing I learned is like that stuff can actually like escalate very quickly. So as soon as I started having traction, and in my head, I was like, okay, if I hired people now, like I know what they would work on. Like once I got to that point, then things kind of escalated really quick, quite quickly. And, ended up raising some money and starting to grow the team.
Behind the scenes, I'm over here just clodding away. I'll reveal a little bit here.
How so?
Well, I was thinking like, what's the, it's like a just-in-time learning tool, let's just say. So I was like, well, I created a new directory to play with Clauding. I said, let's create the most simple CLI-based to-do list in Python, and let's let UV be the centerpiece of it all. And I mean, it's a Python project. I don't know much about those because I've never ran one, but I can see the usefulness just in the real time of UV. It's super fast. It's obviously one command. UV run runs the CLI, so it's got run command. So it's doing a lot of that user experience direction for things. And, as somebody who runs, I've been building a few CLIs. I feel like that's the one thing you want. You want sort of one easy path to run your project and keep it that way.
Yeah, I mean, we thought a lot about that just because like that was kind of like a major design decision when we were building UV was we want to abstract away like as much of the complexity as possible. So like UV run, when you run that command, it will make sure that your dependencies are in sync with the lock file, make sure that your lock file is in sync with your environment, like that, basically that your environment matches like what your declared dependencies are. It will do that every time you run UV run. And the thing that I think is cool is like, that's kind of an experience you can only reasonably build if you have a really strong performant like baseline, because you can't, if that takes like, imagine that took like 10 seconds, then like you can't have that 10-second overhead every time anyone tries to run a command.
And so, be upset.
Yeah. So like for me, that's one of the cool things where it's like, okay, focusing on performance actually lets you build like kind of different experiences. Because you can build things that otherwise would have been like prohibitively slow before. And so, yeah, we didn't want to have this workflow where like you might run a command and your environment is like stale and you're like missing all the dependencies or something. Like that happens all the time with like NPM and Node and stuff. And I'm like, I don't want that. Like I want the cargo version where like you do cargo run and it like takes care of resolving your dependencies, installing them, and then runs the command with all the right stuff. So yeah, it was a very much, that's probably the biggest example of us trying to like provide a different experience for working with Python.
I decided to install it with Homebrew as well. I don't know if that's anti-pattern because docs don't really mention Homebrew.
You installed UV with Homebrew, or
UV was installed with Homebrew.
Okay. Yeah, that's cool.
That's cool. That's cool. My preferred method is Homebrew because that's my Mac OS, package manager basically. So that's my preferred way versus the, just the ways essentially that script on your web server.
We have a curl script. The reason that we generally recommend installing with the curl script only because it lets you do auto self updates. Like if you install with the curl script, then you can run UV self update. But if you install any other way, we can't really do that because like we're not Homebrew, so like we can't like.
So it goes stale over time, and I might be a few revs behind.
Yeah, but it's all the same binary for the most part.
That's a hidden unknown for me with Homebrew. I didn't think about that, like being out of sync. I guess I know that by nature, but the fact that you have a self-updating thing that's built into the package manager is a nicety that I really want. And now I'm going to go and undo that, and I'm going to install it the right way. So thank you very much. But can you talk about, we just talked about run, but what about init and add? These seem to be like the things that really are the magic moments for anyone using Python in the day-to-day. That's not there otherwise.
Yeah. So like I said, when we did the first UV release, the things that we launched with were like UV pip install and like UV VM. And these are kind of like commands that match how people have historically worked with Python packaging. So it's like, okay, I want to create an environment. I'm going to run this command to like create the environment. Then I'm going to like activate it. Then I want to install a package in it. I'm going to run uv pip install torch or like pytorch or whatever. And so it's very imperative and it's kind of low level because it's like you have this directory on your machine that you're sort of like manually managing. It's like, I want to add things to it. I want to remove things from the environment. And like ultimately we want to get away from that. And so like uv init, uv add, uv run, these are all designed to be very declarative. Like you tell us in your file like what the dependency should be. And then we take care of like taking that declared state or that declared set of dependencies and making them correct on disk. Like you don't have to think about, I'm going to create this directory and add this dependency and add this other dependency. You tell us this is what my project needs, and then we take care of the rest. And so getting there, yeah, uv init will create a new Python project for you, and then uv add, you can just add dependencies to it. And uv takes care of keeping everything in sync. And yeah, there are a bunch of, I mean, we talked about this a little bit earlier, just like taking good ideas. I mean, there are a bunch of ideas in UV too that we've like taken from other tools, even tools that, I know I've talked about cargo, even tools that have nothing to do with cargo, like in JavaScript, a couple tools like PNPM and Bun, probably Yarn too, although I'm honestly a bit less familiar with exactly how their design works. But basically the way that we manage like our cache and do installations that's probably one of the most like, oh, this is like, I never thought it could be this fast kind of thing where people get really confused, which is we use like a global cache. So basically if you install a package once, we put it in the cache. If you then go to a different project and install the same package, we effectively just like symlink that package into your environment. It's not exactly a symlink, but the basic idea is for each package you install, we actually only keep like one real copy on disk, and all your projects just point to that, which makes installation incredibly, like if you are installing something that's already been installed before, it's basically a no-op. It's like, it just points the files to the right place. And that's something that like PNPM and Bun do. And there are different tricks you can do on different file systems to like make that faster or different depending on like what's available. But, again, a lot of it's like taking some of these ideas around like how you can build these kinds of tools in a really performant way and bringing them to Python.
Yeah, that seems like a pretty logical one though. The global cache. Where'd you get that one from?
I think probably from Bun was probably I think I knew PNPM did this for a while. But then Bun, I think, is the one that I probably looked at most when I thought about like how our design should work. But yeah, there are trade-offs to it. Like the main downside is there's kind of two ways to do that. Like one is you can actually use like a hard link, kind of like a symlink. The problem with that is users can poison the cache. So like if they change the files in the installed environment, it will actually pollute the cache and affect everywhere else. So let's say that you open a file that's in your virtual environment. It's like add a print statement or something to debug, which is something that people have done from time to time. That then gets it sort of like poisons the cache, so that it also affects other projects. That's one downside. But like Mac OS and some other file systems support a concept called copy on write, or like ref linking, which is much nicer. The idea there is it's like a symlink until you edit it, and then it then it actually writes the copy and changes it there. So that's kind of like the best case scenario. But yeah, it's a very nice idea. And it also means that you, in addition to being way faster, you save like a ton of disk space. So like in Python especially, packages can be really big because a lot of the time you're actually working with native code. So like PyTorch, for example, like it's almost like, I think the Linux CUDA like 12.8 builds are about like a gigabyte compressed. So when you install that package, we're actually like downloading and unzipping like a gigabyte compressed. And so it's really nice to only have one copy of that package on your machine. Like if you're installing a new one in every environment, the disk space actually adds up like tremendously. So it's faster and it's more space efficient, which is pretty nice.
Is the UVFS, when I browse the crates directory in the project, is that literally a file system? Is that what you mean by FS?
It does mean file system, but it's really just like utility functions that operate on the file system. So do things like creating symlinks and stuff like that. Yeah, we have a pretty like unconventional structure to our Rust projects. We tend
It's
to break
easy
them.
to browse.
Thank you. We
Yeah.
have a lot of crates. You can probably see it's kind of like we have a lot
It's
of.
very ceremonious. I mean, you got tomls everywhere. You got source directories everywhere, which I think is I've leaned into Rust a little bit, and you can appreciate the verboseness of Rust because there's explicit returns of types. There's explicit types, obviously. There's so much in there, but I think what it offers you is confidence and safety, which is probably why you chose it as the reason to change what you've done and go build these, build Ruff and then build this, build Ruff and then build this. That's what I see there is like, that's just seems to be the Rust way is more than necessary by means of confidence.
Yeah, it's been I think it's a really good language for building this kind of tooling. I don't think it's the right language for everything. Otherwise, I probably wouldn't be building Python tooling. I'd be building Rust tooling, I guess. But like, it's I think it's a very good language for building this kind of tooling.
Which one's your favorite? Which one do you like more?
Which programming language?
Python or Rust? I mean, you're building Python tools to bring more Pythonistas, but you're building them in Rust, so you must like Rust.
Yeah, I mean, I would say I prefer writing Rust to writing Python, but it's just well, first of all, like I write a lot more Rust than I do Python now, so I've just spent a lot more time in the ecosystem, and Rust is, I think, actually quite a hard programming language to learn, because I don't know. It depends a lot on your background. For me, it was a hard programming language to learn because my background was, I'd done a lot of Python, but also a lot of TypeScript, like maybe like 2 years of Java professionally, like a little bit of Go, kind of barely, and then like not really any Rust. So I didn't have like a systems programming background, and I wasn't really used to this idea of thinking about, in Rust you would call it like ownership, but thinking about like memory management. And so when I first started writing Rust at my last company, someone else introduced it to the project, a really great engineer, and but I didn't really like know it. And so every time I went in there, I was trying to get in and out as quickly as possible. And like I was thinking in terms of Python and trying to map that to Rust. I was like, why is it so hard to like do a comprehension over a hash map? And basically like nothing made sense to me. And so it took me like working on Ruff and kind of building something from scratch and kind of banging my head against those concepts. So I think really understand like what the language is about. And the thing is now Rust has this mechanism called the borrow checker, which is like the thing that makes sure that you don't break its rules around how memory works. And it's not really like writing Python or JavaScript where you can just like create things and like pass them around and do whatever you want. You have to follow certain rules that the compiler enforces. The thing is, for me now, I don't really think about the borrow checker anymore because I've written a lot of Rust. So I think in terms of that kind of ownership, like the thing that makes it hard, eventually that kind of goes away in my experience. It's like, I just write my code now in the way that I kind of know will work for the borrow checker. And I don't really feel like I have a lot of overhead from it. So that's like the thing that makes Rust hard, I think, at least when you're beginning, is the borrow checker. And that kind of dissipates over time. And then it just becomes a lot easier. I mean, there's still plenty of things I complain about. Like I would like compile times to be faster, for example, et cetera, et cetera. But I do find that the way I think about programming now is better to Rust now. And so that ends up being kind of an easier experience for me.
Can you give a little bit deeper dive on ownership and borrowing in the vein of memory and memory safety and memory usage and how it just, once a variable goes off scope, it just falls off? Can you speak to that a little bit? Do you know much about that? Obviously.
Yeah, I can try. I don't know that I'll give the best explanations of these things.
Give us your best take then. How about that? That way, everybody who's thinking about Rust, what I've learned about Rust is just that, is like that is the centerpiece of what makes Rust so safe, is this borrowing method. You can't allow a variable to be mutated. I think you can only have one. This is where I was hoping you could fill in, Charlie, but I think you can have the variable used all the places, but you can only mutate once or borrow plenty. It's like that's the rule thing that you have to abide by.
Yeah, I mean, I don't even know if I've even tried to explain this before, so I probably won't do a very good job. But like, if you're writing like C for example, like I have not written a lot of C, but I wrote some C in college. And so when I wrote C, I had to think a lot about like malloc and free, like allocating memory and then freeing it, and thinking about like, okay, who's like allowed to free this? And like, how do I make sure that like after I free the memory, like no one's like using the object and stuff like that. In Rust, you don't have to like think that way because the compiler does it for you. But the trade-off is the compiler enforces these rules at compile time. So the rules are things like, okay, like whenever you like initialize some sort of variable, like someone has to own it. And when that owner, like maybe it's like an attribute on an object, like when that owner goes out of scope, that value goes out of scope. So if other people need that value and they have to read from it, you have to make sure that the owner lives basically longer or as long as the things that rely on it. And so whenever you end up like initializing memory, like a string or something, you need to think about, okay, who owns this and who's going to need it? And like, how do I make sure that that owner lives long enough? There are a lot of things in Rust, like Rust enforces all these rules, and then you can also break them if you need to in sort of like special ways. And Rust also has a lot of escape hatches for kind of like different ways of managing the memory. Like I actually found that a lot of that stuff made the language more intimidating for me. Like when you go read Rust guides, there are certain things like ref cell and like RC and like blah, blah, blah. And it's interesting because like those things exist in some ways to help you. Like often if you reach for those, it's actually a sign. If you're an experienced Rust programmer, this isn't true. But as a beginner, I found that whenever I was reaching for those, it was actually a sign that I was doing something wrong. Like I was thinking about memory the wrong way. Because like ref cell, for example, lets you do like interior mutability, which is just, it's not super important what it is. But the idea was, I was like, oh, I need to have like write access to this object here. But it's only letting me read from it. And I would like Google that. And then I would find like ref cell. And I'd be like, oh, okay. But actually I was just like thinking about things incorrectly. Like someone else should actually be owning it. Someone else should actually be doing the mutation. So for me, it was like, I tried to start by like, once I figured that out, I actually like ignored a lot of things in the language for a long time. And I was like, I'm going to try and write really dumb Rust. And then I kind of grew to understand those things over time, especially as I hired people into the team who are honestly like much better Rust programmers than me, and I could like learn from them. But I do sort of maintain that I think it's kind of an intimidating language to learn for that reason. Like the mental model around borrowing is just very different. There is a lot of stuff in the language to help facilitate that because it's like one of the most important concepts. But you know, the upsides that you get with Rust are like, it's actually, I think, a little bit hard to appreciate like I suspect that I don't fully appreciate it because I haven't spent a bunch of time writing in memory unsafe systems languages. But like in Rust, it makes it hard basically to make mistakes that otherwise would be very easy. And the cost is you have to play by those rules.
Yeah. And when you compile, you get yelled at. So, you know, good luck on that part there. And it also happens in compilation, not in production necessarily. I pulled back some of my rules. I'm not sure if this will just maybe pepper and spice up what you've shared here. So the 3 rules on ownership are this. Each value has a single owner. When the owner goes out of scope, the value is dropped. That means it's out of memory. And then the last one is there can be multiple immutable references or one mutable reference, but not both. And
yeah, so the not both is also critical. Yeah. So basically, like you can't have people who are allowed to read a value while someone else is allowed to write to it.
Because it would do what you just said with the global cache before. It would corrupt it, essentially.
It would do, it would cause
polluted or what was your terminology. Yeah. And I think I've never written C, and I've really never written systems languages beyond my dabbling in Rust recently ever. So my only experience with it is the knowledge I've gotten from Rust, but I can appreciate what people have complained about C and the reasons why people push up back on C-based network tooling, because that's where there's so much, critical nature to being safe, being memory safe.
Yeah.
I can appreciate this ownership model though.
Yeah. I remember recently, or maybe a few months ago, there was a big, there was a story in Hacker News about I don't know, like an LLM finds a use after free vulnerability in some C project. And I was reading the write-up about it, and they were kind of like tracing through the code, where basically, it's written in C, and like someone was doing something after a variable had been freed that was like not allowed. And I was just looking at the code and I was like, how on earth are you supposed to keep track of this as a programmer? Like, this just looks impossible. There must be so many of these out there. And anyways, reading that actually, it had nothing to do, for me, the experience actually had nothing to do with the LLM being involved. It was just actually looking at the vulnerability and being like, wow, how would you possibly keep track of this? And that's why, anyway, I shouldn't speak to it too much because, again, like I haven't written a lot of C, and like there are other things people do to try and mitigate against these things. But I do feel like in Rust, I took for granted for a while that basically we built like, a couple tools that we get, I don't know, like 100 million installs a month, like maybe more. Like we've built really popular things. And I don't think we've ever had a single like memory related vulnerability, which is or error even, like that I can think of. And it just comes from working within the language, which is cool. Like it's easy to take that for granted. And it's like not why I started using Rust at all. Like I started using Rust because I wanted to build something fast. Right. But there are these other benefits that over time I've just come to appreciate a lot.
Let's focus on fast, because that is UV's selling point. I assume it was Ruff's selling point to a certain extent. I remember looking at Ruff and seeing like how fast it can lint things compared to other things that are linting things, which really speaks to developers, because like we don't want to wait around for anything, let alone a linter. I'll just turn it off. I'm not going to sit there and wait. How much of the speed that you're getting with Astral tools, I guess we can take Ruff and UV specifically, are just fast merely because you just did it in Rust instead of Python? And then how much of it is fast because of some, smarts you got in there, Charlie? Like what your decision to be on that one of like architecturally different?
Yeah. It's a great question. I think it's pretty nuanced and will be hard to put numbers on. So like, I guess the way I think about it is like, we get some baseline from like being written in Rust. That's like probably faster than like the baseline that we would get from being in Python. But Ruff, Ruff as an example, has actually gotten like significantly faster over time. And it was always written in Rust, right? So like, there's like a big, so you're doing stuff. There's a huge delta that you can get even within just like being Rust. Like an example is like at one point we rewrote our parser, like the thing that takes Python source code and turns it into a syntax tree that we can analyze. And like, the initial version we used was based on something called a parser generator, where you kind of like write out your grammar and then it generates the code for you to a certain degree, which can be really handy if you're working with something, which you're building a parser, because often you can describe a parser in terms of the grammar. Like, okay, you have the def is a keyword followed by the function name, blah, blah, blah. Right. And we ended up rewriting it to use, I guess, what would be called like a handwritten parser. So we got rid of the parser generator and we kind of like wrote it out ourselves, and it became like way faster, and like several times faster. It made Ruff as a whole like 30 or 40% faster. And so that's like the same, that's all within Rust, right? But it's like about thinking hard about how you're doing things. And, it also varies a lot. Like even if you look at Ruff and UV, because in UV, we're doing way more IO. And so a lot of being fast, not all, but a good chunk of being fast is trying to be smart about how you do IO, because we're either like downloading things from the network, or like writing things to disk, or like reading things from the cache and writing them somewhere else. And so like I talked about the caching trick earlier, like you could also do that in Python. It would probably be, the program would probably be slower if you wrote the exact same program in Rust and Python for a bunch of reasons. But you could also do that to write a faster version, in Python. Right. In Ruff, that tends to be less true. Like in Ruff, there is IO, like we have to read the files, but like beyond that, it's a lot more, I guess, like a compiler. Like it's kind of like has to parse all this source code and then figure out how to efficiently like traverse it and collect diagnostics and report them back. So, I think Rust like gives you a better baseline, faster baseline.
How much better? And then, like twice as good, 3 times as good?
I don't
over
know.
the
It depends what you're doing, but yeah,
over the
I
same
think at
Python
least-
program. Well,
yeah,
a Python-based linter and a Rust-based linter doing the exact same linting, same
the
file.
exact same stuff.
I mean, obviously those are rough numbers. No, pun not intended.
Yeah, I don't know. Probably like somewhere around an order of magnitude is what I would
Okay,
expect.
so that's significant. Okay, keep going.
Yeah, for sure. But I think the other thing that I've come to appreciate with Rust is like it kind of like gives you the tools that you need to like optimize further and think really hard. Like allocating memory is like pretty expensive, and so in relative terms, and so like a lot of what we think about when we try to optimize things is actually like how can we allocate less memory, or allocate memory less frequently, or whatever. And like in Python, it's actually just pretty hard to have control over that because like you don't really have any control over like the allocator and like where memory is getting created or destroyed.
It's definitely not staring you in the face like it is in
No,
Rust.
but in Rust, yeah, you're kind of thinking like we did this whole thing where I went deep I gave a talk at Euro Rust where I like went through the exact design here, but like when you run UV, we parse a lot of versions. Like it sounds like a silly thing, but just like package versions. Like for a very complex resolution, that code might run like 10 million times or something because like just parsing versions. And so we saw that showed up in a flame graph and like when we were profiling, and we redesigned how we represented versions. And we came up with the scheme whereby like 95% of versions, something like that, can be represented in a single U64 integer. Like we encoded them as an integer. So it's like, okay, the first 8 bytes are the major version number, right? The next 8 bytes are the minor version, et cetera, et cetera. And that actually had like a very measurable speed improvement. And like, that's not really something that you could think that would be intuitive to do or very easy to do in Python. Like in Rust, we have to think about how are things actually represented, for example. And so again, it's like, I guess for me, it's like, it gives you a faster baseline, then it gives you the tools to care about this stuff if you want to. But certainly like some of the things that we did in UV especially could be taken and used in other Python package managers written in Python. And like, that would be if they want to do that, I think that would be a good thing. Like, I'm very happy for that to happen, but it ends up being a mix.
So your first product is out. Yes.
Yes. PYX.
What's it called? Is that how you pronounce it? PYX?
Yep.
Okay. PYX, a Python native package registry.
Registry.
Registry. So you've learned a lot from all these other tools, open source world. How much have you studied NPM Inc?
A bit.
A little bit. So surely you want to avoid some of the problems that they've had. And I'm curious the design of PYX and the ambitions here and how you're going to go about building a registry that's commercial.
Yeah, I mean, it's a little bit different because like we're, at least right now, we're not focused on this being like a public registry. This is a tool that's designed for companies. Like we work with lots of companies that either already pay for registries and we think we can build something a lot better, or need to adopt some sort of internal, registry as they grow, or like have problems that we think we can solve with the registry that we actually couldn't solve like just with the client. And so for us, it's like, how do we go and help more of those users and like fit the needs of those companies while continuing to build out like the open source. So, commercially, like for us, we're not looking to like charge money for like Ruff or UV. Like we view that as our like open source tooling, which we want to remain free forever, very permissively licensed. And what we're trying to do instead is kind of build these paid services that are complementary and are sort of a natural evolution if you're already using our open source tool. So like I said, we talked to tons of companies who use UV. They buy registries. So we're going to go offer them a registry, and we think it's going to be better in like a variety of different ways than the things that are out there already. So like a lot of why we built this thing and are building this thing comes from, like I said, or as I alluded to, like problems that users have brought us that we can't really solve like in the open source. Like, maybe people will come and they're using some private registry and it behaves in a way that's like incorrect. And we're like, okay, we actually can't help you anymore because like that's a problem with like the software. And so just being able to offer them something different, I think is one manifestation of that. But the other is like, sometimes people want to install packages that are like broken in different ways, or maybe there aren't builds available for like their Python version, or maybe there aren't builds available for their GPU or something like that. And in that case, again, that's not something that we can solve with the package manager, because to solve that problem, we actually need like a server that has like artifacts that we can manage. And so again, it's like looking at these problems where we've spent a bunch of time in the issue tracker trying to help people and ultimately concluded that there's only so much we can do, and saying, well, what if we had our own registry, our own server? Couldn't we do something pretty different?
That makes tons of sense. Is there a world that you can envision in which Astral would want to host a public registry to make UV better in some sort of way that you can't do it as just a client?
Maybe. I guess anything's possible. It's not like in our current mission for the problems we're trying to solve here. And I guess what I would prefer to see happen is like PyPI, which is sort of the Python equivalent of NPM. It's like it's the public registry that people use by default. It's run by the Python Software Foundation, so it's owned by a nonprofit. I want to make sure that that has longevity and continues to evolve and be stable, because I think it's a really, like, I'm happy for that to be kind of like the public system of record and for people publishing packages in the way that, most people are maybe installing packages. But for us, like, we mirror that stuff in, for example. So like you can use PYX to install things from PyPI, and we're not necessarily focused on like the public serving. We're more focused on what's the experience we can build around the raw artifact storage. And are there like other things that we can expand to over time that aren't a registry, but are related to hosting and serving artifacts? Like we've also thought about like code execution, for example. Like maybe you should be able to execute code through our tooling, and maybe that would have some tie-ins with the registry too. So for us, it's not like, we're not like a registry company. Like we're like a company that's trying to build this whole Python developer experience, and the registry is kind of like the first extension into building something beyond like a command line tool. So it's like a big new thing for us. But the thing I think is most exciting is just that we can actually like solve a bunch of new problems for users that we basically couldn't solve before. And I think one of the things that's interesting about building in Python is like the user base is incredibly diverse. What I like to say is like every company on earth is using Python for something within some margin of error, but like the things they're doing can be super different. Like we have, we talk to users who are like, you have 15 million line code bases that are running web applications. That's like all Python. And then there's like AI and ML, everything that's happening with GPUs. That's like super different. Even if you look at a company like OpenAI, like the things that they're doing with GPUs are even super different. Like half the companies like research and half the companies like applied, like ChatGPT, and like that's all super different. So, for us, it's also about trying to figure out like where can we have the biggest impact, like which of those user groups, and what can we build for those groups, because the things they need are pretty different. And so that's always been something that's on my mind, is like how do we serve like all those groups, and how do we figure out like where we can have the biggest impact? And the registry is sort of another example of that, where a lot of what we're building there, not all of it, but a chunk of it is actually focused on GPUs and like people trying to install hardware accelerated packages, basically things that involve CUDA or like NVIDIA GPUs. And that's like relevant to some people, but not to others. But for us, it's kind of about figuring out like where can we have the biggest impact with this? Like now that we have a server where we can host artifacts, like where can we have the biggest impact amongst all these different people using Python?
What does it mean to be GPU aware then? Like why is that such a... Take us into the details of why that's a problem. How does it manifest outside of, was it PYX? And then how do you solve that?
Yeah, so it's a problem for a couple of reasons. So like in Python has actually very good support for like building and distributing native code, like native binaries. And it's part of why it's been such a success, it's both a result of and why it's been a big part of data science. Like if you think about installing NumPy or something, like, most of that is not Python. It's like a compiled binary that's like native code that's compiled for your machine. And when you go to install NumPy, you don't actually have to build that from source. Like you don't have to download the compiler and like compile everything yourself. What happens is when NumPy does a release, they publish, I promise this will get back to GPUs, but when NumPy does a release, they publish builds for Linux, Windows, Mac OS, Mac OS ARM, like M1, M2, like Mac OS Intel, x86, all the different Python versions. So they pre-build these things and they put them on the registry. And the package manager knows how to look at your machine and figure out like which version of which NumPy build is right for your machine. So that's like very central to Python. It's where a lot of complexity comes from in packaging, but it's also like kind of a superpower because you can build like UV, you can install UV, you can like pip install UV. And that's just a Rust binary that we basically turn into a Python package and publish. And you don't have to build it from source. Like Python standards let us do that. GPUs make things harder, in part because of some of the gaps in the standards. So like in the standards, there's no way to express that like I just built PyTorch and it was built for CUDA 12.8. Or I just built PyTorch and it was built for CUDA 12.6. Or I just built PyTorch and it was built for like AMD ROCm. These are just different kinds of GPUs. There's no way to actually express that. So when they build PyTorch, they go and the PyTorch team builds PyTorch for a bunch of different architectures. And they basically have to hack in the way that they do this. Like they have to just like find ways to encode it that aren't really codified by standards, which leads to a lot of complexity. Like there's no way in pip, for example, like let's say that you have an NVIDIA GPU on your machine. There's no way to do like pip install torch and like get the right torch version based on your GPU. Like it just, there's nothing in standards that would really allow them to do that. So that's kind of the problem that we want to solve, which is like,
so what they do.
There's actually a second, what they do is they publish the different version of torch. Each architecture basically gets its own registry.
Wow.
So they create an index for CUDA 12.8, an index for CUDA 12.6. And on the 12.8 index, they publish the builds that they built for CUDA 12.8. And each library also solves this in a different way. So like JAX, which is like a Google library for working with GPUs, does like something totally different. So yeah, there's been a lot of experimentation around trying to make this work. But it ends up being pretty difficult. And there's sort of like a second order problem, which is that there are packages that build against PyTorch. And so it's not just like PyTorch needs a GPU. There are also other packages like VLLM, extremely popular piece of software for actually serving language models. Like if you actually want to do like run an endpoint that like runs a GPU to like do predictions and give back data, you would use VLLM for that. That has PyTorch as a dependency. And when they build VLLM, they not only have to encode the GPU version, but also the PyTorch version. So it gets very complicated very quickly. And that's kind of like the complexity that we're trying to tame with the registry. So like GPU aware means a few things. One, it means that UV, the client, can actually figure out like what GPU you have on your machine. And then it can map that to basically the right endpoints in PyX. So in PyX, we have like curated distributions based on the hardware. And we go through and we not only take like PyTorch, but we also like pre-build a lot of other stuff that people commonly use with PyTorch. And we make sure all the versions are compatible and all the metadata is correct. So we do what I would call the sort of like non-glorious work of like making sure that all the things we put on there, it's like a well-curated distribution. And in UV, you can just like install, we'll look at the GPU on your machine and we'll pull in the right things from PyX. So that's like one tack that we're taking on this problem, which is we just want people to be able to like run on a machine with an NVIDIA GPU or an AMD GPU or whatever, just run like, UV add, torch, VLLM, flash attention, and not have to think about building from source, not have to think about where these coming from, not having to think about making sure that like the CUDA versions are all lined up. Like that's like part of the complexity that we're trying to solve.
Is that ability to see the GPU particularly, is that a Rust level thing that UV inherits?
No, you could do that anywhere. And like a thing we're trying to do in parallel actually is like standardize a lot of this stuff, like actually evolve the standards so that these things can be encoded. We've been working on that with like the NVIDIA team and the PyTorch team. It will take a long time. It may also never get accepted. Who knows? Standards are hard. Like we're working on that. But that would also involve similarly like trying to detect and understand like what GPU the user has installed. Mm-hmm. The thing that's a little different, I think, like the thing that is hard for others to do is like, because we work on the package manager and the registry, we can actually encode that contract of like, okay, this is the user's GPU. So like, this is where you should be getting the packages, for example, or like, this is like constraints that the server needs to understand. So like we can keep those APIs in sync and make the experience really good. Ultimately, hopefully this stuff gets standardized, but until it does, there's like, I think it's like hard to appreciate like how big PyTorch is. Like we spend so much time like helping people install PyTorch, not in terms of size, in terms of like the wheel, but just like, or the artifact, but just in terms of like how big the user base is and the community is. Like we just spend a lot of time trying to help people install this stuff. And it's gotten a lot better. And I think the PyTorch team has actually done quite a good job in the face of these sort of gaps in standards and like having to trailblaze a lot of this stuff. But you know, for us, it's like, we're kind of like user obsessed. And so it's like, I hate seeing people struggle to install this stuff and I want to find ways to fix it. And so for us, some of that's in the UV client and some of that's in the registry.
So PYX, your first commercial product, but not necessarily like the future of Astral, because you're not a registry company. You don't want to be necessarily a registry company, but it's a revenue stream. It's another opportunity to make UV better for your customers who need it, but maybe just one of your products down the road, right? Like this is one thing we do. We have other things we do as well that we're selling, making our investors happy without making your investors mad. Like what are some of your other ideas? You know, they don't have to like spill all the tea, but like what other aspects of Python tooling could you tackle, whether in open source, I know you got your type checker going on, or on the product side.
Yeah,
what else are you working on?
Yeah, I mean, in the open source, it's, I mean, there's no shortage of like things that people have asked us to do in the open source. And I mean, my philosophy, which we'll obviously stick to as long as we can, is that if there's a problem that we can solve in the open source, then we should solve it in the open source, like not with a commercial product. Like, again, we'll see, we'll get tested on that over time. But like, I would like the incentive structure of the company to be such that we're very much incentivized to like build things in the open source and grow the open source. And that the paid and the hosted products represent real value that can't go in the open source for like structural reasons. Like, you know, like in the registry case, it's like, okay, security, compliance, like all these things that don't really make sense to put in the open source in that way.
Right.
So there's no shortage of things that people have asked us to build in the open source. I think the things that we are building now, which I'll just like maybe mention again, is we're building a type checker and a language server. Probably like very comfortably the most technically difficult project that we've worked on. It's very hard. We're looking to do the beta release for that. I can't really say the date, but let's say, you know, within the next few months. So that's something that we've been asked about forever, basically, has been like a type checker.
The language server you're referring to, or the type checker?
Both.
Okay.
Yeah.
Because the language server is at least out there, right?
They're all out there.
Oh,
yeah. We did an alpha release. Well. We've done an alpha release, and we do have companies using it in production. We just haven't gotten to the point where we recommend it for use in production.
Okay, so the type checker / language server, like it's one.
Yeah,
thing.
They're the same thing. It's called TUI.
Gotcha.
Yeah, and it's a little bit like TypeScript in the sense that like it's a command line tool, but you can also run it as a language server.
Gotcha.
The other things that we get asked about a lot in the open source are testing, like a test runner. That's kind of an interesting one for me. A lot of people actually really like PyTest, which is like a very popular, probably the most popular Python test runner. And so I think I would need to think hard about like, why could we build something that's a significant improvement over PyTest? Like it has to meet some bar of like, it has to be much better, hopefully, than alternatives. Otherwise, why would anyone use it or switch to it? And another thing we get asked about a lot, although it's a bit more niche, is like documentation tooling, which is not super glorious, but it is a big part of. It is again something that Rust does very well.
It's also highly appreciated by the Python community, right?
It is. Yeah. It is. Yeah. I think the thing is, like, the thing that's maybe a little challenging is the user base for that is slightly smaller because it's mostly oriented around maintainers and people who publish libraries.
Yeah.
Most people are using libraries, not writing libraries. So, but again, this is all just about obviously we would do everything in the world if we could, but ultimately everything has to be prioritized. there's sort of like a thing that is a little bit more pie in the sky that like we do not have any plans to do this, but it would be cool if we could, which is our own Python runtime. So like actually trying to make Python itself faster or different in different ways. Because right now we actually do our own builds of Python that we distribute. And it has a bunch of modifications versus CPython, but those modifications are really in the build process. And they're all motivated by this same idea, which is we want to be able to pre-build Python for you that you can then unzip and run. Because CPython itself, like CPython main, doesn't really support that for technical reasons. Basically, a bunch of absolute paths get encoded in the binary when you build Python.
Is it different, like it's statically linked, or it's like different sort of?
We do statically link things, but ultimately, like the main problem is that CPython, when you build it, at least on Linux and Mac OS, encodes a bunch of absolute paths.
Okay.
And so we have a project called Python Build Standalone, which the core idea there is like you can we build it and then you can literally just download, unzip it, and run it on any machine. It makes it relocatable. You can move it around your machine, et cetera, et cetera. So it's basically patches and changes in CPython to enable that. But we don't change anything about like runtime behavior. And so again, we do not have plans to do this, which I have to be like really, really explicit in saying.
If you were going to, though, however, what would just say?
What a big lift that you just described, though. I mean, that to me would be like just overwhelmingly daunting.
Well, this makes me think about the dreaded GIL, right? Like I would imagine if you did do this runtime, it would not be written in Python or C because
the GIL is potentially not long for this world.
Yeah,
I don't know if you've been following that.
Oh, okay.
But yeah,
they're free threaded now. You know.
Yeah, free. Yeah.
Or at least you're
not supposed to call it no GIL. No GIL was the original name for it, but now it's called free threaded. The idea, so in 3.13 or before 3.13, they sort of provisionally accepted a proposal to remove the GIL. And in 3.13, there's a separate build of Python that has no GIL. And then the idea is eventually that will become the default. But right now there's kind of a split world.
How does that work with legacy Python out there, though? You know, it's good for future, but what about the past?
As in Python code that is written in a way such that it assumes the GIL exists?
Well, maybe take this as my imposter system here, not writing a lot of Python, but if I'm writing Python, I suppose against a version that supports the no GIL method, then that's probably just fine. But if I've got code that's legacy that's written in, Python, but against older versions, am I still at risk of the issue of the GIL, I suppose?
So you possibly are. And that's part of why they're doing this incremental transition, whereby also like if you try to install like NumPy, for example, again, just going back to NumPy, like something that has native code, they have to build a special variant for no GIL for free threading. So basically all the libraries have to add support for this. And like audit their code and make sure that they like work in a no GIL world. So like, especially the extension modules especially have to like explicitly go through a process of adding support for this. So it will take some time. And that's also why it was like provisional acceptance and kind of like something that got staged in. But, I guess a cool thing for us is like we've made it really easy to install the no GIL version. Sorry, not the free threaded version of Python because
I like no GIL better personally, but
I know, me too. But that doesn't always work out the way we want.
It's a spade, called a spade, right? Like there's no GIL.
I didn't really participate too much in that conversation at all, I guess, in that conversation. But I think the concern was that a lot of people don't know what the GIL is, and so they wanted something that was descriptive, also in a positive way, rather than something a negative, not as in like negative sentiment, but just in terms of describing what it is rather than describing what it isn't in a way.
I like free threaded because it just reminds me of, Freebird,
Yeah.
It just feels
I haven't thought of it that way, but I guess I could.
Or we used to hold a lighter up at the concert.
Now it's a phone,
But now everybody holds their phone up anyways.
Yeah.
Free threaded, Freebird.
Yeah, so
anyway.
Yeah, I mean, we actually have this guy on our team named Carl Meyer, who's like super amazing. And before this, he worked at Meta. Meta has a fork of CPython called Cinder. And it's sort of a performance-oriented fork. It is open source, but it's not really open source in the sense that people run it outside of Meta. It's just sort of open source in the sense that the code is open source and they use it as a reference. But Cinder was this performance-oriented fork, largely, if I understand correctly, built with Instagram in mind, because Instagram is all Python. Instagram is this big, very high, obviously very high volume application. And so they did a bunch of things in Cinder to try and make Python faster, or I guess make Python faster, not try. I think they did make Python faster. And it had some very interesting ideas. They tried to upstream some of them. So for example, Cinder added lazy imports. So like in Python, imports are all eager. So when you run like import whatever, at the time that Python interprets that import statement, it goes in and like parses all the code and actually like executes all the code. And that cascades down. So basically when you start up your application, if all your imports are at the top level, you kind of like import the world, and that can lead to like slow cold starts and a variety of other problems. And so Cinder added support for lazy imports. And then they tried to get that upstreamed a few times and it failed. But we have a person on our team basically who worked on Cinder, and he worked on Cinder's JIT, which they did a bunch of interesting stuff to try and make Python's JIT, like Python's JIT compiler faster. And so basically we have people on the team who understand how to work on the CPython interpreter, but I don't think that we're at the point where we...
So you're saying there's a chance.
I'm saying there's a chance. No, I don't really want to do it. I mean, for me, it's like, I sort of look at these things from a few perspectives. One is like, it's good to be a little bit naive, because otherwise, if you're not like a little bit naive, you just like won't try anything hard, because it's just too easy to say like, well, a bunch of people have tried it. Like, of course it can't be done. Right. So I like being a little bit naive, but at the same time, you also have to have some like humility and be like, okay, a bunch of people have tried this. Why didn't they succeed? And like, why could you succeed where they didn't? So you kind of have to thread the needle, I think, a little bit between like being incredibly arrogant about being able to solve any problem and being like a huge naysayer who just says like, well, that can't possibly be made better.
Especially while there's lower hanging fruit. Like you have a list of things that you're currently prioritized, which arguably, I assume you would argue this, is higher value for less work, right? Like it's lower hanging fruit than that particular fruit up there, because that one's way up high. And so maybe you could do it, maybe you should do it, but clearly right now you're focused on other things.
Yeah. I mean, I think
maybe when you raise your next round.
Yeah.
Well, I come back to the why. I mean, like on this subject, I come back to the why. So you mentioned like the being naive. I think that's true. There's been some efforts with prior art to do some version of a runtime. I think there's even like Rust Python out there. I think Dropbox had one that made it faster, but they abandoned it. So like there may be some, maybe sadly to say it like this, dead bodies out there that you have to sort of like navigate. Like maybe we shouldn't go there because it's already been tried before. But coming back to a why, and you mentioned being you want to build in the open, you want to incentivize your company to build in the open. And so I can just come back to that why. Like hypothesize with us for a moment. If you did do something like this, what would be the why? How would you quantify the why from a business owner, CEO, founder, investors, all the things? Like how would you prioritize or think about the why of writing a runtime for Python in Rust?
Right. I think that's probably one of the reasons that I don't know that we do it is like so if I think generically about that question, in terms of like the business strategy, it's like the open source, like ignoring the Python runtime for a second and just thinking about our existing tools. The existing tools that we build give us a couple of things. So one is they give us like a lot of distribution. So, we're building a registry and like we have all these people that use UV. And so we have kind of a natural audience of people who maybe want to try the registry. Also, intimately linked to that is also brand. Like I actually think a lot about brand. I think brand is maybe a little bit of like everything around like developer marketing and brand is kind of like seen as like slightly dirty if you're like an engineer because it's not technical. But like I actually think brand is like incredibly important. and for us, it's like, we built Ruff, and then when we came out with UV, people were like, oh, they built Ruff, so like this might be good. I should give it a shot. And then we see that I view that as kind of compounding. Like I want to like earn users' trust and prove that we can build great things. And so that all accumulates in brand, which again ties back to distribution. It's like if we build a registry, people hopefully think, okay, that will probably be good because these people built these other good things. The other things it gives us are, I think we have interesting like technical advantages across the stack in a few different ways. So like with the registry, for example, I actually want to like pull in our type checker in some interesting ways. Like I want to be able to do things like detecting like semver incompatibilities like within the registry, like understanding if a new version of a package comes out, like can you upgrade like without having to like, or are there breaking changes that affect you, or like security scanning, like if a vulnerability comes out and a package and we know that you're using it and we have like a really good understanding of your code, like we might actually be able to tell you like if whether you're affected or not. So like for me, it's also about trying to compound these like horizontal, like technical advantages across the tools by like bringing those things together. I think for the runtime, it's like, if you think about the why would be like user impact. But like, it doesn't necessarily enable us to do a lot of things that we otherwise couldn't do, at least right now, unless we built it with specific technical ideas in mind. Like maybe we decided, okay, I'm just making this up on the spot. It's really not something I've thought that much about, but it's like, okay, we want to build a version of Python that's like maybe we really want to focus on like WASM or something. I don't know. Maybe we have use cases where we want like WASM to be like we want to run this like on the edge, like in the CDN or something. And we're going to go all in on like that idea. So I think we'd have to have some idea that basically enables us to do and offer things that we otherwise couldn't offer.
Distribution's a really good reason.
It is a good reason.
I think,
yeah.
More UV out there means more Python out there. More Python means more UV users.
Yeah. I mean, I do think also like if I not to be too like full of myself, but it's like, I do have to think a little bit too about like, how do we make sure that Python keeps growing? Because that's important to us. And so if there are like big existential problems in Python, like if we thought packaging was an existential problem or something, then it's like, okay, let's try to solve packaging so that Python keeps growing, right? Like, so there is a little bit of that too. I don't think like the runtime is, I'm not suggesting that the runtime is in that position. I'm just saying that like, there are benefits for us in helping grow Python. And so if there are things we think we can do to help grow Python, like those could be worth doing, even if they're not connected to like a concrete like product offering that we charge money for. Again, I'm not suggesting that the interpreter or the runtime is in studies. I think that's actually in a very good state.
We're just hypothesizing about, I think, learning from the past to save the future from itself. I mean, we're just doing what Rust is doing.
I'm just saying that in terms of things we choose to work on and why they're worth working on, one of the considerations is just like, how do we help grow Python and like make Python more popular and bring more people into Python?
One more question on this, maybe too far, but I don't think so.
You tell us, Charlie.
And the reason why, I think, so if you're concerned with somebody being offended because we're hypothesizing about a future that doesn't exist, and if it should exist because you have business interest and vested interest in Python growing, I think that's silly to get upset with that. So if that's you, chill out for a second. Do what you can, given how you've improved other Python tooling, and to the degree that you have improved that tooling. If you did undertake a runtime, what benefits do you think you could deliver just by nature of what you've done already with Rust tooling for Python? Besides just simply speed, like enumerate specifics if you could.
I think there are things, again, we're just speculating here.
Just speculating.
I think there are things that would be interesting to consider changing around like how this sounds small, but sort of like how environment discovery works. So like right now, like basically, I guess the way I'd put it is take things that actually happen in UV run and see if you could make them part of the runtime is maybe a way to put it. So if you're in a project and you run Python, like run that in the context of the project, as opposed to just like trying to find some global Python interpreter, basically trying to make Python the runtime more environment aware and like project aware, I think would be something that's kind of interesting that we could do. So trying to like smooth out some of what we see as the traps that users run into. I mean, I'm sure we would initially be drawn in by performance if we thought we had ideas that we could pursue there. But again, like there are plenty of people working on CPython runtime performance. And, I think there's maybe actually like a slightly different, like the thing that Bun is doing, which is like maybe interesting, but also maybe like potentially a trap, like kind of remains to be seen. Not for users, but just in general, is like they're building out a pretty large standard library. I guess standard library is probably the right word. So like in their standard library, they actually have like, probably get a bunch of this stuff wrong. Like I think they have like an S3 client. I think they have like a Redis client. I think they have a database client that understands like MySQL and SQLite, and like they have like all this stuff. So the idea is like you can just like work with Bun and like import all those things, and you don't have to worry about going and finding third-party implementations, and they're all like natively implemented. I think there is something interesting there. I think there are absolutely downsides to that, but I think there's something interesting to that, which is kind of providing like a trusted, if you can build a strong enough brand and build good enough implementations, providing kind of trusted implementations for all these things that people need in building modern applications, I think is kind of interesting. But again, I don't know that we would ever do that. But the idea of trying to provide really good implementations of all these things that people commonly need, to first of all, to provide better implementations that are faster and also reduce the surface area of things they depend on, I think is kind of interesting. You could potentially do that, by the way, without actually forking the CPython runtime. Right. But I do think it's kind of, I think it's an interesting direction.
Let's take a moment to reflect on brand, because you mentioned it as something that you think is important and that a lot of software people don't necessarily think about. I'm a fan of yours. I think specifically speaking to astral.sh, I think it's a nicely designed website. I appreciate that you have bucked the trend of going following linear down the road of like dark mode everything. I like that there's some brightness going on. Talk to us about brand, how you think about it, why it's important. By the way, the font is really sweet. I'm not sure what that is, but that your Y is really cool looking, and the G's are nice too. So
thank you.
You've got some taste, in my opinion, or at least we share tastes. You know, there's no accounting for taste, but
yeah, whether they're good or not.
We have similar tastes at least. So I think they're good because they align with mine. But yeah, talk about brand, why it's important, how you think about it, how you attack it. Because in my opinion, that's another thing that's setting UV and Astral apart. And it's kind of one of those things that you don't think about right away. It just is there. And so your thoughts?
Yeah, definitely. I mean, I think like, I don't really explicitly think in terms of like developer marketing, but like when I first started, like when I first released UV, I was trying to just explain to people as quickly as possible, as succinctly as possible, why they should care about this project. And so the README for me, like the top of the fold of the README had to capture that. It had to capture like, why is this interesting? And I remember when I did the launch too, I had like a little graph that was just like a benchmark graph of like UV Ruff versus like a bunch of other things. And like, I think that graph was like very important for like conveying to people the significance of like what's happening. So like for communicating to developers, or communicating to anyone really, it doesn't matter if they're like developers or not. It's like, you have to assume that you have basically like you get like no attention. Like if you write a blog post, for example, you have to be thinking in terms of most people, they might read the headline and they might read the TLDR and they might look at the one image at the top, but they probably won't read any of the text. Some people will, and it's important to care a lot about what it says. But like you have to be thinking in terms of, how do I explain to people why they should care about this as quickly as possible? So like even just by thinking about that and productionizing it, I think you will, as an engineer, you'll probably be doing more than a lot of small. Also, by the way, caveat before we get into the actual interesting stuff, you definitely don't have to care about any of this if your goal is not to make your project very popular. Like you can just build stuff and publish it and not care about this at all. And I think that's totally cool. But if your goal is to get people to use your thing and care and follow along, you know, I think this stuff matters a lot. A lot of how I think about brand too, like it's very holistic. So like when people come to our repo and like they file an issue or like they ask a question in Discord or something, like I would always view those moments as like, I have an opportunity here to like make a friend or like win a fan or something, or win someone who's going to support the project. And so like you try to compound that over time. And so when people would come in, first of all, when I was starting the project and anyone would come file an issue, I would just be so excited that they cared at all. And I would kind of just focus on how do I give these people a great experience. And over time it becomes, even if I'm going to say no to what they're asking for, how do I make sure that they have a good experience? Like, as in they feel heard and respected and they understand why I said no. And we've just focused on that a lot. Like, we try to be really responsive in the open source, and we try to like give people a good experience. And it takes a very long time for that to have an effect. But like compounding over years, I think it's had a huge effect on like our open source community and like how people view the project. And you have to take a very long-term view towards a lot of these things. But again, that's all connects to me to brand. Like, brand is not like, it is the visual identity of the company, but also it's like, what do people associate with it? And I want people to associate with us what I hope is true, which is like, we want to be good, responsible, like approachable, like open source maintainers who are demonstrating like responsible stewardship for these projects, and that people can trust us. It takes a lot to keep this up too. Like, doing the open source, like even just trying to be really responsive in the open source is like a huge investment of our time. Like, we could probably have the whole company like just maintain the open source and build nothing new, and that would still be like full-time work for us. But it's also like, with everything we release, we want to like maintain the quality bar that we have. I think maybe actually a good example of something that we've tried to put into our brand is like, we try to fix things really quickly. And so even if we release something that's broken, we'll fix it really quickly. And that actually, I think, has become a really helpful part of our brand, because if something's broken, we fix it quickly, and then it gives people more trust that like, if something breaks, we will fix it quickly. If we ship something that's not finished, we'll fix it quickly. So I think I just take kind of a pretty long-term view towards a lot of these things, and I try and think really hard about like, if I were a user, what would I need to hear, or what would I need in order to use this thing? On the visual brand, we worked with, some designers to like do the initial branding, and I actually showed them a bunch of examples of sites I didn't want to be like. I didn't just show them positive examples of things I thought were interesting. I also showed I obviously won't name any of these companies, but I just showed them companies where I was like, these to me feel very derivative. Like, Vercel and like Linear have really amazing brands and design.
Yeah.
But then so many companies have tried to just be like Vercel or Linear.
Right.
And I was like, I actually want to do something that's like pretty different. Like, it should still feel professional, but like, and well done, but I want it to be a little bit distinctive. And so it's very much intentional, I think, that it looks a little bit different than a lot of other developer tools.
Well, that's one of the things that grabbed me, because as somebody who's steeped in the industry, as Adam and I are, and we see lots of company websites, lots of open source project websites, there is this, what used to be the old bootstrap effect, right? Like, you could tell when you saw a bootstrap website. Well, now it's like, you can tell when you see a VC backed open source, website, because it's like, they're basically derivative. I mean, not all of them are. Linear, I think, started it all. Vercel does have amazing work done. And so a lot of that is just like, well, those look good, I'm going to copy that. And that, I got no problem with that. Like, if there's more important stuff to do, fine, go ahead and do that. But I've been waiting for a turn in the trend. Like, who's going to come out and be different? So I'm just applauding you for that reason.
Yeah, no, I appreciate it. Yeah. I like I don't know, like Sentry is kind of an example here too, where it's like, they have a very different brand.
Yeah, Sentry does
have a very
have a
distinctive brand. And like, some people don't like it, some people love it. Like, I mean, like Posthog would maybe be another example. They have like a totally crazy brand.
They do. Their website. You see their redesign? Their website is crazy right now. It's like,
I did.
It's like an
but they really lean into it. It's like, it's everywhere.
Yeah.
It's like they're like real world advertising. Like, everything is like,
right.
Just
well, you said it, like,
crazy.
love it or hate it. Like, those are two strong emotions, right? Like, you're gonna remember it. Like, I knew exactly what you were saying when you said Sentry and when you said Posthog.
Right.
And whereas there's lots of them where I'm like, I can't remember what that brand was. But anyways.
Yeah. I mean, I think it's been interesting for us too, to like try to figure out how to kind of like connect our open source to the brand. Cause there's like, I think there are actually a bunch of people who don't realize that like our tools are connected, or that there's like a company behind this work. And so it's been kind of interesting for us to think about like how to like communicate that to, like, over time it happens, but like, we definitely have people who are like surprised to learn that like Ruff and UV are related, for example, or that there's like, or don't know that there's like a company behind these things. And so those are like sort of separate challenges, but that comes up too.
Mm-hmm. One thing I go back to, and it just stems from the things y'all are saying, is like most, like those websites that are not to be named, they're beautiful, but they generally suck in some way. And the reason why I think they suck in some way, and really by the main thing is like, if you land on it, it's really hard to understand what they do. It's some sort of like pie in the sky marketing pitch rather than something as succinct and just like compressed as next gen Python tooling. And I think that's the promise you were delivering. I think that's the thing that I think is challenging with a lot of these and I evaluate a lot of them too, because we work with a lot of different brands to, by way of understanding who they are, so that we can take their message and help them communicate it to our audience in a way that isn't marketing, but it's a story of who they are, why they built what they built, who uses it, and how they benefit from it, and how they, the audience, may also benefit from it too. Too often I'm just like lost in my journey, my personal journey, because that's my job is, who are you? Why do you exist? Why should our audience care? And how can I help you tell our audience in a way that respects them as developers, respects them in terms of their time, and helps them truly learn and be educated about that tool, that company, that thing, that service.
Yeah.
And I spent a lot of time just figuring like, what do you do? And your homepage doesn't always, not yours, but the proverbial your.
Yeah.
Often just misses the mark. It's like, bento box this and sliding thing there. And it looks really beautiful, but it's like, can you please just show me the tool? How does it work?
Yeah.
How am I going to use it? And I think that's the challenge.
I mean, I think the other thing that I found is like, I can't really like outsource like voice. Like all the copy on the site, like I like did myself. And it's like, cause I just think a lot about, I guess just cause like I've spent my whole career as like an engineer, and like, I'm not like, I know what it's like to like land on those sites, and I know what it's like to like when people speak to, especially to like engineers or technical audiences, in a way that feels like authentic and a way that feels like inauthentic. And so, yeah, I mean, I guess the trade-off is I spend so much time on like any public messaging, like the PYX announcement blog post, or even like the Twitter thread, like none of that stuff is like off the cuff. That stuff's like, I'm spending like a week, like writing a draft, throwing it away, getting feedback, like writing a draft, throwing it away. So like, I spend a lot of time on like, basically on like our public messaging and the things we say. And I've sort of just accepted that like, that's just a thing that takes me personally a long time. And like, I have to go through a bunch of drafts, and I have to like have a few chances to look at things with fresh eyes, which means it takes time because I need to like step away from something for a day and come back and read it. And like, so anyway, I guess my point is just that it takes a lot of time, and I think it's hard to fake, and it's hard to outsource.
Yep. Totally agree.
Well, we've kept you here a long time. We appreciate you chatting with us.
It's been super fun. Yeah, we've gone in a lot of different directions. I appreciate all the great questions and all the interest in letting me talk about some fairly obscure technical things.
That's fun.
That's what we do here. Yeah, that's what we're all about.
That's the good stuff.
Yeah.
We enjoyed it for sure.
Yeah, I've learned more about Python and Python packaging over the past 2 years than anyone should know. So like whenever I can find people to listen, I'm like very happy to chat about it.
Well, PYX is what's next. Astral.sh. That's ASTRAL.sh
/PYX.
Yes, go there, check it out. It is the next step in Python packaging. Join the wait list. There you go. If someone
don't brew install.
Don't brew install.
Curl install UV.
Yeah, curl install UV.
Yeah.
No, just install UV however you want, but you should use it.
Yeah, come on.
It's great.
Do it the right way.
Very good. Thank you, Charlie, for sharing your story. Awesome.
Yeah, thanks for having me. Take care.